All right, so we're given an equation here, y is equal to 2 minus 3 times the sine of x. And with this, remember, the first thing I said we want to look at is the basic shape. What trig ratio are we given? What trig function? Here it's sine class, and sine's key points.
0 and 1, 0, 1, 0.
All right, then I look and I see, okay, I notice there's a 3 right here. What does that do?
Amplitude.
It's the amplitude. It's going to stretch everything. So instead of only going up to 1 and only going down to 1 class, instead it's going to go all the way up to 3 and down to -3. I also see a negative right here. What's that going to do? It's going to invert the whole thing. It's going to flip it. So actually, instead of going up to a 3, I'm going down to a -3, and then instead of down to the -3, up to a +3. And then also see this 2 at the beginning. That's going to shift everything up 2. And anytime you shift, remember, my recommendation was, let's go ahead and put a prime axis. So since we're shifting up 2, the recommendation, remember, would be to put an x prime axis here that's shifted up 2 units. I remember, by the way, in setting up your axes, remember, give yourself plenty of room on the positive side. Every 3 boxes is a quadrant. So pi over 2, pi, 3 pi over 2, and 2 pi as you're setting this up. And remember, every 2 boxes is another numeric value, 1, 2, 3, 4, and so forth. Remember, 2 pi is approximately 6, so it's 12 boxes over. I'll end up getting something like this. Questions on this first graph? You vaguely remember doing this at the end of the first quarter and early second quarter. Let's do another one. I'm going to go and set up a new graph here to make it easier for Chris to see. You can use the same Cartesian plane if you would like for this next one. Any questions here on the sine curve? Let's take a look at the tangent curve now with one little change, right? But again, I always like to start by looking at the dominant function in the problem to get my key points. What are tangents' key points?
Asymptote 1, asymptote
0, asymptote 0, 0.
Yeah, it starts at a 0, and then the next quadrantal is the asymptote, then back to 0, back to asymptote, back to 0. So if we were to graph this, I'm going to start with a 0, and then asymptote, 0, asymptote, 0. But I shouldn't have done that on my graph grid because I'm going to be doing what to my graph?
Horizontal shift.
I'm going to be shifting it horizontally. How far?
One box. Pi over 3, so 2.
What is pi over 3?
60 degrees.
60 degrees. So that's 1 box or 2? Ethan can't make up his mind. 1.5 boxes? Well, think about it this way. 90 degrees is pi over 2, right? So every 3 boxes is a full quadrantal. So 2 boxes, right? 30. Basically, every box is 30. So we're actually going to shift in which direction? Forward or backward?
Forward.
Forward. Remember, the horizontal shift is
Remember
weird.
that.
A negative shifts it forward, and a positive shifts it backward. So we're going to shift it forward 2 boxes. So really, let me switch to yellow because I'm too lazy to erase the pink. We're going to start at this point for 0, and then 2 boxes later than I originally put. There's my asymptote. Then here's my 0. Here's my asymptote. We're going to end 2 boxes after 2 pi. So we're going to start 2 boxes late. Now, in between the 0 and the asymptote, exactly halfway would be your tangent of 45. What's the tangent of 45? 1. So we're going to have 1s in between, of course, negative in the second and fourth quadrant, positive in the first and third. So exactly halfway between the 0 and the asymptote will be at 1, negative 1, 1, negative 1. Remember, the key is to curve. So curve and approach but don't touch. Curve and approach but don't touch. Curve and approach but don't touch. And curve and approach but don't touch. You should get something like that. All right, questions on that one?
So, how we know where to put the one at?
It's always halfway. So here's my 0. 3 boxes later is the asymptote. Come in a box, and a half is where it'll go up to 1. The other points, if you wanted them, remember, at 30, it's square root of 3 over 3, or 0.6. And then at 60, that's square root of 3, which is 1.7. So I mean, if you wanted those extra points to help you get a really good curve, that would be great. But at the very least, getting those points, the 1s at the very least. Let's do one more. And again, if you at this point, if you haven't switched to a new graph grid, you probably need to. And let's go this time with y is equal to 1 plus the cosine of 2x. 1 plus the cosine. Actually, let's make that a negative 1 plus the cosine of 2x. I like that better. Negative 1 plus the cosine of 2x.
Pizza day, by the way.
I know. I'm watching the clock. That was actually Jamie's first question when she came in. How's this going to work? So again, first thing I look for, key points. What are my key points, class?
1, 0, or negative 1, or 1, 0, negative 1, 0, 1.
Good, starts at 1, 0, negative 1, 0, 1. But, some thoughts.
There's negative 1.
I'm sorry?
Change signs of all.
Ooh, careful, I'm not inverting. This positive doesn't invert. Now there is a negative, but it's not on the function isn't made negative. Like on the earlier one, where we had y is equal to 2, negative 3 sine x, the sign itself is negative. Now there was also a numerical coefficient, but the sign itself was negative, which flipped it. The cosine is not negative, so we're not flipping anything.
Negative 1, when you go,
It shifts the whole thing down 1. So again, here would be a great opportunity to use that x prime axis. All right, but what else? There's one other little subtle change here. Is this 2? Does this change the amplitude? Should I do 2, 0, negative 2, 0, 2? No, that would be if it was multiplied in the front. When it's multiplied by the angle, what is it changing? The period.
yeah.
Remember, this number can be represented by the letter b. And the period of sine and cosine is normally
2 pi.
2 pi, but really it's 2 pi over b. Well, in this case, since b is 2, that means the period is simply pi, which means all of this is done by the time we reach pi. So starting with this as my 0, I'll go up 1, and I'll have to end 1 by the time I get to pi. So here at pi, I've got to end at a 1. Halfway in between, I've got to go down to a negative 1. And halfway in between the 1 and negative 1 is a 0. And remember, resist the urge to make a V. Instead, make sure we curve it. Of course, if we wanted to, I could draw a second period by the time we get to 2 pi. We see the full period completed by the time we got to pi. I'm actually really wondering how well the pink is showing up. So, in case it's not showing up well, I'll retrace it in yellow for you there, Chris.
Lemonade color.
What?
Lemonade color.
Lemonade color? All right. All right, questions on graphing. And this is probably one of the things that's been the longest for us, so a good refresher for us as well. All right, in addition to these things, make sure you know your limited domain, or your domains and limited ranges of your trig functions. Remember, for both sine and cosine, what's the domain of arc, sine and arc cosine class?
1 and 1. Or infinity. Or negative infinity.
Limited, their domain for arc sine and arc cosine. I've heard a gazillion different answers. One of them is right.
Negative 1.
It's negative 1 to 1. That's the limited domain. It's what you can take the arc sine or arc cosine of. What about for tangent and cotangent?
Negative infinity.
Negative infinity to infinity, and then for arc secant and arc cosecant.
Negative infinity, negative 1, and then
1
1 to infinity.
Good. Negative 1, negative infinity, negative 1, 1 to infinity.
Um,
What about the limited range of arc sine?
Negative 9 and 90.
In brackets. For arc cosine?
Bracket 0, 0 to 180.
Bracket 0 to 180. Arc tangent?
Parentheses 0 to 1.
Parentheses
90 in parentheses.
0 to 9.
Parentheses negative 90 to 90. Arc cotangent?
0 to 180 in parentheses.
0 to 180 in parentheses. Arc secant?
0, 180 in brackets except 90.
Good. 0 to 180 in brackets except 90. And then arc cosecant?
Bracket
Negative 90
90
in brackets except 0.
Good. Negative 90, 90 in brackets except 0. Remember, the only issue with your calculator is arc cotangent of a negative.
I have
That's
a
the
negative.
only real issue you've got
It's
is,
not negative, it's okay.
yeah, as long as because if it's positive, it'll spit out a quadrant 1 answer, which is great. Quadrant 1 works for everything. But tangent tries to pull a quadrant 4 answer. Our cotangent has to have a quadrant 2 answer, so how do you compensate?
At 180.
You add 180. Normally we add 360, subtract 360, coterminal angle. That's one time we'll actually add, subtract 180. All right, I believe we have now gone over everything on the exam between last review and this review. Tomorrow will be your opportunity. We have a short review period before the exam tomorrow. We'll be recording, and we'll call it lesson, I believe, 86, and lesson 87 is the exam. But in lesson 86, it'll be your opportunity for anything we've reviewed the past couple of days to say, hey, can we go over that again? So tonight, your only homework is figure out what you're still a little shaky on so I can help you with it tomorrow. All right, you'll be dismissed. Have a wonderful rest of your day.